Hi everyone, welcome to this month's webinar. We're going to be doing a bit of a deep dive into controlled vocabularies today, and I'm delighted that there's been so much interest in this month's topic. We have some fantastic speakers from the Vocabulary Management Group at the British Oceanographic Data Centre today, who will be taking us through the basics of what a controlled vocabulary is and why they're important, all the way through to some more technical information about semantic models, linked resources, and accessing vocabularies in a more programmatical way. So hopefully, no matter what your experience with controlled vocabularies, whether you're just hearing about them for the first time today, or if you're already using them in some way, there'll be something new for you to learn today. We'll have time for questions after each presentation, so feel free to drop your thoughts and questions into the Q&A as we go, and upvote any questions that other people have put in as well that you're interested to know the answers to. As you know, these webinars are hosted by the Marine Environmental Data and Information Network, or MEDIN. And this topic is really important to MEDIN because we rely heavily on controlled vocabularies within our Discovery Metadata Standard and our data guidelines. The vocabularies that we use ensure that metadata submitted to MEDIN is consistent, searchable, and interoperable across organisations and platforms. And with that, I will hand over to our first speaker, who is Danny from the British Oceanographic Data Centre, and she'll be giving us an introduction to controlled vocabularies and their importance in fair data sharing.
Thanks very much, Rosanna. Hi, everyone. Thanks for that. Just quickly share my screen, start the presentation. Brilliant, thank you. So yes, hello, everyone. My name is Danielle Wright. I'm from the British Oceanographic Data Centre, part of the National Oceanography Centre in Southampton. And yeah, I'm going to introduce you all to the concept of controlled vocabularies and their importance in fair data sharing. So I'm going to set the scene a little bit and imagine that you are a scientist and you might be going out to sea and collecting quite a diverse array of parameters. And in doing so, you sort of already understand that, for example, dissolved oxygen measurements you might be measuring from samples are going to be comparable to those that you might have obtained from an in situ sensor, for example. You don't question the fact that these were sort of measured in water, or even what the concept of depth means to you in this kind of context and situation. All the metadata that you record alongside all of this data sort of places them in their geospatial and temporal context. You understand why you're doing this, why you're collecting the data, and what the information means to you. So that's all fine. You've collected your data, you come back, you might go away and then process it all up and make it available on the web via a DOI, or digital object identifier, which is sort of a permanent web address. So that's all great. What happens next? And you know, who else is going to be able to discover all of this data that you've collected and processed? So in this state, generally it's only sort of other humans who might already know that this data set exists. They might sort of know that this project exists, so they know where they might be able to go to search and find this data. So how can we kind of increase the discoverability of this data set that you've put out there on the web? So to do that, we want to go back to the metadata that you've collected alongside this data set. So that's sort of what you've collected, when, where, how, why, and by who, whether that's you as an individual or organization. Because without all of this extra information, that data really are just kind of just numbers. And, you know, we need all of that additional context to understand the data. There are some problems with this because generally this type of information is written as free text, which is very much open to human error. Also, we're very good at talking sort of, we can use different language to describe the same thing. We're very good at doing that. So I've got a couple of examples of that here where, you know, we've got pavement versus sidewalk, trousers versus pants. So this is where the idea of standardization is really important when we're talking about describing metadata. And there are examples of this throughout our everyday lives where information is kind of standardized. You know, look at our postcodes and car number plates. You know, information is structured in a specific way so that consistent meaning can be derived. So how do we go about recording our metadata in a standardized way? So this is where the idea of controlled vocabularies comes in. So these are collections of unique terms or concepts that are grouped by a common theme. And, they're given a label, they're defined using unambiguous language. So they're assigned a definition. And each individual concept is assigned a permanent, what we call URI, or unique resource identifier. So it's got its own place on the web that is linked to that definition. So where can you go and find control vocabularies that you might be able to use for your data sets? Well, here at BODC, we host the NERC Vocabulary Server. So it's a semantic repository for standardized terminologies. You can use these to annotate your data sets sort of within the marine and sort of related domains. So not only does it store the actual concepts, but we also host and manage the mappings between terms as well, which is sort of the relationships between different terms. One of the collections that is used quite a lot, quite heavily, quite broadly, is called P01, or the parameter usage vocabulary, which is used to describe those individual measured phenomena. And if we go back to our oxygen example from the start, we can see how this is represented in P01. So we've got the label at the top, and it's assigned a definition. And you can see the URIs it's associated with there. And the key takeaway from this is that if you start annotating your data sets directly with those URIs, then you're starting to become machine readable, which is what's really important. So now imagine that you're a user and you're looking to sort of search for some data sets on the web that meet certain criteria. So you might be interested in all the oxygen data from the North Atlantic, for example. The key thing about this is that by annotating data sets using those URIs that match those criteria and have definitions that meet those criteria, not only other humans, but now machines can start to understand that this data set over here is sort of semantically connected and linked to this other one over here, all because they're using the same vocabulary concepts to describe the data, essentially. So it's not only humans, but now machines that can discover and access these data sets. And this leads me quite nicely into sort of findability, accessibility, interoperability, and reusability of data, which are the sort of the four FAIR principles towards data sharing. And it really does allow data providers to sort of structure and annotate data sets specifically for the web, all towards the sort of what we call the semantic web sort of linked data. And vocabularies really do sort of underpin the interoperability side of that. And yeah, although it goes towards sort of connecting the dots between data silos and making all of this information machine processable. So going back to our oxygen example again, we can see how we might look to mark up some of our data and metadata with some controlled vocabulary terms. So the ship we might have gone out on, the RRS Discovery, that can be found in the IC's platform codes C17 collection. The sensor that was used to measure the oxygen can be found in the L22 measuring devices catalogue. And I've given an example here of 3 different P01 oxygen parameter terms that you can find. There are obviously many more than 3, but I've just given an example of 3 different ones here that can all be sort of differentiated by the different methods used to obtain them. So I suppose the result of all of this is that this work is all allowing data sets to be findable and sort of accessible and searchable, all because of the use of the URIs, basically. And through the DOI, we also know where that data are located. So everything's now standardized, machine readable, and, through sort of, it's increasing the amount of data that we can use in sort of a knowledge, like a data lake type thing, for want of a better word. So it's all towards generating greater knowledge and insight for policymakers and other researchers than would be possible if it was just us doing it alone without the use of machines in pulling all of this information together. But yeah, moving on to the MVS as a whole, sort of in operation, it really is becoming used sort of on an international scale worldwide, and it underpins the elements of several large observation networks. some of these you probably have heard of, but you know, there's the CDataNet infrastructure and the eModNet program throughout Europe, which we're quite closely connected to. There's the Argo Floats program. They now host all of their collections on the MVS. We are quite heavily involved with OBIS, Ocean Biodiversity Information System, as well as IC's International Council for Exploration of the Sea. So we host their platforms vocabulary, and we map quite a lot of our parameters to their parameter lists as well to ensure that there's that linkage. It's important to note that this work is by no means complete, and we face several ongoing challenges in ensuring all of this works. So the need for international collaboration is quite a big one. We are heavily involved with a lot of key communities, but there's always that need to, you know, get involved with other communities, and a lot of communities don't always have that buy-in yet into why it's impactful and how it can benefit them and others. You know, we have to adhere to common standards, which are ever evolving, so we have to be open to adaptation. And, you know, the MVS has historically had quite a marine focus, and, you know, in the future, we're going to have to be able to be interoperable with different disciplines and domains, and that's going to be an increasing challenge, I think. And obviously, being able to keep up with technological advances. I thought I'd just introduce quickly how you might go about searching for different collections and concepts on the MVS. So we do have a website which has a search tool. If you already know, if you're looking for a particular term and you already know which collection it sits in, then you can enter that into the first search box at the top. If you are looking for a term but you have no clue what collection it might sit in, or you want to see similar terms across a range of collections, then you can use the middle option. And if you're looking to search for sort of the collection as a whole, then you can use that final search box down the bottom. And you can also explore the mappings between different collections as well. I thought I'd also highlight the CDataNet thesaurus search, which I think is quite a nice visual way of searching. And it's kind of, you start off with a broad category, and you can then drill down through the hierarchy of sort of narrower and narrower collections until you find the terms that you're interested in, basically. So, you know, if we go back to our oxygen example, you might start at chemical oceanography. It then brings you to dissolved gases. It then brings you to dissolved oxygen parameters in the water column. And that's where you find all those concentration of oxygen parameters. So that's quite a nice visual way of doing it as well. This is also just for you guys to note. General help and advice, you're always welcome to contact the Vocabulary Management Group at BODC. We have an email address, so that's useful for any help and advice or guidance, or for requesting a new collection. I realise I've put that under the GitHub thing, but it's probably best to email us about a new collection. Yes, we do have our own GitHub space, NVS-vocabs, and yeah, we'd definitely advise you going to GitHub to request new terms. We have an individual repository per vocabulary collection, and yeah, it's open to anyone to create a new ticket. Just one thing to note is that some communities do have their own GitHub spaces as well. So the CF conventions, for example, and the Argo community have their own GitHub spaces. But you know, if you're not sure, we can help point you in the right direction. And that's everything. Thank you.
Thanks, Danny. If anyone has any questions, don't forget to please put them in the Q&A. I've got just a couple of easy ones to get us started. I was wondering if you knew how many vocabulary collections are hosted on the MVS.
Yeah, so I think there's just over 300 now, about 303 that are live. So there's quite a few for people to explore. And I think that amounts to about 180,000 individual concepts. That includes the sort of, we call them semantic elements, or the building blocks that can make up a whole concept as well. There's quite a lot.
That's really impressive. Yeah, lots. And then I was also wondering, what's kind of the recommended best practice for annotating a data set with controlled vocabularies?
Yeah, so that does kind of depend on the file format that you are using. But But it essentially boils down to the fact that you could just replace whatever free text you have been using as your column header, for example, or your attribute, and replace it with the URI, and that really does start to unlock things. Yeah.
Thanks, Benny. Not seeing any questions in the Q&A just yet. We can always come back and answer any questions that come through after Alex's presentations as well. So I will hand over to Alex now for her presentation on semantic models and linking of MVS to other semantic web resources.
Hi. Okay, you can see my presentation. Hi, everyone. So I will be talking about semantic models and linking NVS to other semantic web resources and initiatives, continuing from Danny's presentation. So before we start, because I don't exactly know what the audience is here, I would like to have a few definitions that are not absolute, but they have been adopted in the wider European Open Science Cloud and internationally, I would say. So they were brought up first by the Fair is Fair project and have been becoming kind of de facto. One is semantic artifacts, which really is a broader term to include ontologies, terminologies, taxonomies, thesauri, vocabularies, and metadata schemas. So we call them all semantic artifacts. The second one is semantic artifact catalogs that encompasses existing ontology repositories, registries, terminology services, and metadata schema registries and catalogs. And then the last one, you probably have been hearing this one, which is crosswalks and mappings that we possibly all know, which are links or associations or even relationships between the content of those semantic artifacts. For example, it's the relationship of the data catalog vocabulary against the schema.org vocabulary. So the way that these two relate between them creates a crosswalk that this is what we will be talking about in some of our slides. So semantic artifacts and semantic artifacts catalogs play a very crucial role in the interoperability framework in the European Open Science Cloud and generally in the international interoperability frameworks. So here is where they are: mapping repositories, semantic artifact catalogs, and semantics. And NVS, the NERC Vocabulary Server, is actually a semantic artifact repository that hosts standardized hierarchical terminologies that are used in the management of data in the marine and related domains. We store and serve vocabularies that are called collections, and terms and their relationships. So terms are also called concepts, and the relationships between them are called mappings. These are the pillars that NVS is standing upon, and they're very important for our end users to trust what is being served by NVS. The first one is governance, which is really a very, very important one. NVS is a community-led vocabulary, so we do have many communities, as Danny said before, and they can collaborate through GitHub, and they are supported through the vocabulary management group that also manages the NERC Vocabulary Server. We publish vocabularies following the standards, the current standards, and we follow what is happening. So we publish in the resource description framework RDF using different serializations like XML, JSON, LD, and Turtle. We also publish our triples through a triple store, which is published as a Spark endpoint. And we use different vocabularies like the OWL vocabulary, Dublin Core, the PAV, and of course, the simple knowledge organization system. We do follow the linked open data standards and I will talk a bit more about them in the next slides. As for APIs, we do publish all the NVS vocabularies as APIs, RESTful, Sparkle Endpoint, and SOAP, and we do have a human interface that is being created by a technology called Vocabularies. Dani presented the tools that accompany NVS, and they're all here to search or create new vocabularies. And we are monitoring how NVS is performing through an internal dashboard monitor, but also an external monitoring system called Argo that is provided by CDataNet. This is a slide that shows all the different connections that NVS's members have with international bodies and initiatives. And that is to show that we do involve ourselves with all these bodies to influence them, but also get influenced by them. First one is the European Open Science Cloud, where we are members of the Semantic Interoperability Task Force, but we are also co-chairs of the opportunity area for ontologies and metadata area in EOSC as well. So we do influence and get influenced by them. We are also co-chairing 2 groups in the Research Data Alliance organization, and we adopt the outputs of the groups that we participate. In this row, I show you different links of how we implement what is coming out of those groups. Fair sharing is a website or a portal or a registry of different standards, and we have a DOI of the NVS listed and featuring in the fair sharing repository. We are part, as Dani said, of CDataNet and Blue Cloud, and not only part, but we underpin the research infrastructures with our controlled vocabularies, but also providing semantic brokerage. I'm not going to talk about OBIS because Dani said so. And for the CF, the standard names, we host vocabularies that support the CF convention and the CF standard names, and the vocabulary is the P07. We also provide instrument vocabularies for the rolling deck to repository, which is a whole program. Some of our vocabularies are published through the Earth portal, which is part of the Onto Portal Alliance. We have worked with the Fair Impact project, and we have published a new API for NVS that I will talk to you in the next slides. And we also are part of the cross-discipline interoperability framework, CDIF. And now, so what I think is very, very important and easy to work with is to go to the first page of NVS, to the vocab.nerc.ac.uk. And here is all the information that you need. So in this space, you can find all the links to look for vocabularies, terms, mappings, and anything related to vocabs. You can pick tools. They are either created by us or by our collaborators, because vocabularies are open, so you can build on top of them. So you can also consume vocabularies through the APIs that we offer, so Sparkle, SOAP, and REST. And then you can also use content negotiation, so ask for the specific content that you want of a certain source. And of course, you can still request, NVS is a live vocabulary source, you can still request new terms and new vocabularies. Here, I wanted to show you that in NVS, each vocabulary has a unique URI, and you can follow this pattern to find, to request vocabularies. Sorry, that was wrong. This is the right URL. But we also have unique URIs for concepts. And this is the pattern. But we also have unique URIs for mappings. So we class mappings as a first-class citizen in the semantic. So we have unique URIs for collections, or vocabularies, concepts or terms, and mappings, which are relationships between concepts. Now, a collection can have many concepts, and then a concept can have many mappings. The types of mappings we offer are internal, so between concepts within NVS, or external, so between a concept in NVS and a concept outside of NVS. They can be hierarchical, so it will include, they would be broader, narrower, or inverse, and then they can be associative, either same as or related. And we also have some more expressive mappings that use different ontologies like the I-adopt, QUDT, and PUV. So this is the list of vocabularies that we use for the mappings. So SCOS, OWL, I-adopt, PUV, and QUDT. And these are the mapping URLs. So they can be internal mappings or external mappings. They look in a machine-readable context like that. And we use the SESOM vocabulary to express our mappings, which is what is the standard for expressing mappings in the semantic in our domains. Standards and technologies, as we said, if you go to the vocabularies page, so if you click on vocabularies, then you land into this page. And here you can learn that we use SCOS, the Simple Knowledge Organization System. We operate over a Spark endpoint, and we use different serializations that are really a way to express RDF or hierarchies in a format that computers understand. So it's either XML, Turtle, or JSON-LD. And we also offer alternate profiles, so different views of the same thing. And here is what, if you click on the alternate profiles, this is the page you will land on. I would like to draw your attention on these two columns, the token and the formats. The token shows you a few different terms here, like NVS, SCOS. This is the vocabulary that we use to express our vocabularies, or the ontology that we use to express our vocabularies. So NVS is our default, but we have used several others. IOP is the I-adopt ontology. And then in this column, you can see the different serializations or formats, and RDF XML is our default one. Whenever you click on each of those links, you will get a URL that will include a profile and a media type. The profile will have a value that comes from the token, and the media type will have a value that comes from the formats. So if you want the media type to be, let's say, JSON-LD, that would be application/LD plus JSON. So it will come immediately if you click on that, but if you don't and you want to programmatically create it, you will have to work with the profile and the media type. MOD is our latest API development. It's something that we created along with the FAIR Impact project and with many semantic artifact catalog creators you can see some of them here, like Cosmos, the Onto Portal, Showvoc, the OLS, Aberol, VocPress, we did it, and then our creators will follow, and many more, so that we make sure that all of us are interoperable with each other. And this is how the mod API looks like in our Swagger documentation. So we had these endpoints and we increased them to have those ones as well. And I think that's the last one for this presentation. And is there any question I could answer? Or we go to the practical guidance on Sparkle? Rosanna.
Thanks, Alex. There's a couple of questions that have come through on the Q&A as you were presenting, so I'll read those out and we can answer those. I'm not sure if it's best that you answer them or Danny, but we can sort that out as I read them. So the first question is, if I store a term URI in the attribute of my data set, how does the data search work? Should I store a term label in the second attribute and implement search on the label attribute, or what's the best practice to implement data search when terms are in the controlled vocabulary?
So the let me just the attribute of my data set, how the data search works. Should I store a term label in the second? Yeah, it should. So that's actually the directive. We have been working with Fairies project, where we received data sets from different domains, not only the marine, but different others. And what we found out there is that instead of URIs, they had used just free text, but that free text was coming from vocabularies. But we had no idea that this is coming from a vocabulary. So after all this work and analysis that we did with the semantic analyzer, we now know that it is very important to have both the URI and the preferred label, as the person that asked this question correctly said. Yes, it is important to have both.
Thank you. That makes sense. There's another question. So at Helcom, we have identified a different list of human activities in the Baltic Sea than I can find in the NVS. So there's 3 NVS vocabs that they've listed. Should we implement our own controlled vocabulary? Is it possible to host it on the NVS, or should we implement our own vocab server?
I'll direct that to Danny.
Yeah, that's probably something we can investigate. So all of the vocabularies that we host are also assigned sort of a governing body for who has control over the content. So we can probably look at who is involved in those existing collections and, yeah, get in contact with you, get in contact with them, whoever has governance, and sort of, yeah, look to take that forward. Yeah, it's probably, as we already host some of those collections, it probably makes sense for us to also host them, I would say, rather than trying to host your own. Then we're all using the same infrastructure and things like that. So yeah, feel free to get in touch. We can talk about that.
Thanks, Danny. And then there's one more question. Could you please provide a brief definition for the different semantic artifacts, e.g. ontologies, vocabularies, etc.?
Mm-hmm. So I have a slide here where you can see the level of semantics that each one of the different semantic artifact type holds. So at the top, the strongest semantics are on ontologies. It's a conceptualization of a domain. That's what the definition is for the ontologies. And then as we go down, like thesauri, and then just a simple hierarchy, and then a controlled list, the semantics tend to weaken. So one is just a list of terms. The other one is a list of terms that have associations between them, and then others have hierarchies. And then ontologies hold a lot of more semantics, But as we are on the level of thesauri for NVS, we are not an ontology, but we use ontologies to express the vocabularies.
Okay, thank you very much, Alex. I think that's all the questions that have come through so far. So shall we move on to the practical guidance we've prepared? Yeah. And then if there's any more questions, I'll read them out at the end of that.
Brilliant. So Sparkle. I really like the language, so I hope I will share a little bit of my love with everybody else. So Sparkle is a protocol, and it's the query language for the resource description framework, or the query language for triples, because RDF is expressed in triples. So Sparkle let us query RDF graphs using a standard structured syntax. It's like what is SQL for databases, relational databases. Here we have graph databases. So Sparkle is used to query the RDF, search for vocabularies and ontologies, and it is supporting semantic web applications. So RDF is actually a set of triples that you can see here. They all have a subject, a predicate, and an object. For example, Bob knows Mary. Mary was born in Hania. Bob is a person, and Mary is a person. As simple as that. The subjects are either URIs or blank nodes. The predicates are URIs, and the objects can be URIs, blank nodes, or just literals, numbers, strings, symbols. Now, why did we decide to create URIs here and here? Is because we want to use something that everybody else is using. For example, instead of saying knows or is a, I'm using a term that comes from a vocabulary called schema.org. So schema.org has a property that is called knows, and instead of using my knows, I use their term to express that, because everybody else, if everybody else is using the same URL, we will all know that this thing means that I know somebody. Also, instead of saying was born in, I use the birthplace from schema.org, and instead of saying is a, I use the RDF type in both cases. So I have a URL for Bob and Mary, and now I can express everything that I need with a persistent, a unique identifier that I can always click and find what I'm talking about. A very important thing is that in RDF, everything has a type, so that everything is about machines. It's not really about people. So it's important for the machines to know what they are consuming. They are consuming something that is a person, and that person knows what another person. So make sure that you always provide a type for what you give. And from those triples, you can actually create a graph like that says exactly the same things that are said here. They are said in the graph here, like Bob knows Mary, Mary is a person, and Bob is a person, and Mary is from Hania, and Alice is from Hania, and so on. The same logic we used for NVS. And if you learn or understand this, you will be able to do Sparkle quite easily. So again, these are the triples for NVS. We offer 3 types only: collections, concepts, and mappings. So we use SCOS, as we said before, the simple knowledge organization system. So we say that, for example, this URL here if a computer sees that, it knows immediately that it is a collection. And if a program sees this URL, it immediately knows that this is a concept. And if it sees this one, it knows that it's a mapping. A small notice here, a note that we annotate and we refer to our collections, concepts, and mappings with HTTP, not HTTPS, because this is our unique identifier and not our URL. Okay, so always use the HTTP, not the HTTPS. Each one of our collections, concepts, and mappings have attributes or properties. For example, they have a label, or they have a title, or they have an alternative label, and so on. And I'll show you where to find all this information. Another important thing for you to be able to discover what you need from our Spark endpoint is to know that a concept is linked to its parent vocabulary through the SCOS member predicate. So that term here is connected to its parent vocabulary through that SCOS member. This is how a mapping looks like. For example, that this term, SCOS broader that term, really what that means is that this term on the right, the object, is broader than that. It's a legacy. It's something that was used weirdly, but if you want to talk the sentence, you should say that this term has broader concept, that concept. And finally, in the mappings, if you want to look for mappings that have all the mappings of this term, then you should look for mappings that their object ID is that term. So if you learn these triples, and if you keep referring to those, you will be able to find anything that you need in the Spark endpoint. Final note, we do use prefixes. Instead of me writing the whole of the URL of RDF, I use prefix RDF. Put the URL here, and then instead of using that, I use just this prefix everywhere, RDF or SCOS, and I use SCOS everywhere. So we call those prefixes. This is how the graph of those triples looks like. So the mapping that is a SESO mapping, or that this thing is a concept, or that this thing is a concept, and so on, and the relationship between them, that this is a member of that, or that this has member that. The concept. So we have now a concept, and for you to be able to find all these triples and be able to query the NVS, you click, turtle is the most human readable serialization. So if you click on turtle, you will see this. This is my concept. This is where I can see that it is a concept, and it has several properties like the DCE identifier, it has version, it has, for example, a preferred label, all of these properties and their values. The values can either be URLs, they can be numbers, dates, or just simple text like this salinity. We said before about profiles and media types, so I'm not gonna repeat them. And I will just now take you to the basic Sparkle query structure, which has a prefix. As we said before, we declare all the namespaces that we are going to use. If I'm going to use SCOS, it's good to use it here. Your query will run even if you don't use prefix, but it will help you to not have to write all these long URLs. As in SQL, if you know SQL, you select, you choose what you want your query to return. And on the where, this is your pattern matching block that opens with curly brackets and closes with curly brackets. And when you don't know what you're going to get, always use a limit so that you don't end up with a lot of waiting time. So you control the number of results that you will be getting. When you know what you will be getting, then continue increasing it. So as you see in the two screens here, how we write the queries or the where pattern matching space, we actually write triples. And whatever has a question mark in front of it is a variable. So give me things that are, I can name my variable any name, but here I say give me things that, put them in this variable that are of type concept, SCOS concept, and that they have a preferred label, and put this preferred label in a variable called label. So that will return all the concepts and their labels by querying all the different vocabularies. If you noticed, instead of using RDF type, I used A. This is a convention we use in Sparkle. You can either use RDF type or A. It's exactly the same thing to denote a type. So give me anything that is of type concept. I could also say, give me anything that is of type collection, or give me anything that is of type mapping. And then you go back to your turtle, and then you see what else is listed under a concept, and you can actually list it here. So these queries will be executed in our Sparkle endpoint. So you have to physically go to the Sparkle and then write that query in there. This query has one more line that says, give me all the concepts and their labels, but filter so that the label has salinity inside it. And if I wanted to also, instead of not only have the preferred label, but also see the alt label, what I would have to do is to add one more triple underneath here and say that this concept, I want the SCOS alt label, and bring it to me in a variable called alt label, or however you like to name it. Another useful query for you is to be able to bring the terms of a certain vocabulary in your Sparkle endpoint, in your Sparkle query. So you can say, for a certain vocabulary, for example, the P01, bring me all its members and put these values into a variable called member. So then when you run the query, you will see those results. If I add this line underneath, now I'm saying whatever is returned here, so the terms from the P01, give me everything about these terms that is a predicate and that is an object. And I think that, so this is how a turtle file again looks like. This is what you would be looking at to help you with your Sparkle. But for me, the easiest way is to go back to the this slide here, know your types, know the list of properties that you want to get, and start small to do your queries. And that's my last one, and I'm open for questions.
Thanks, Alex. So yeah, any questions, please put them in the question and answers. I have just a quick one. So obviously that was a little bit of a Sparkle tutorial, and also in your previous presentation you mentioned RESTful APIs and SOAP, and I wondered if you could just go through the reasons why you might want to use each way of accessing the NVS. Are there particular use cases where one is better than the other?
Yeah, SOAP is an older protocol. So it was created many, many years ago, but it's very robust, it's fast, but it's old. So at some point we would like to retire it, but because a lot of our end users use it still, we are just maintaining it. We are not expanding it or put things on top of it. Honestly, the Sparkle endpoint is extremely useful because you can ask any query that you like. You are not limited by what the endpoint of a RESTful interface will give you, but you can ask any type of query. I would say we have done so many useful implementations with the Sparkle endpoint, from unit harmonization to parameter harmonization to semantic brokerage, dynamic mappings with using the iAdopt protocol, and so it's a much more useful than any API, according to me. But you have to actually put the effort in to learn a little bit about it. Of course, the RESTful interface is very useful as well for somebody that just wants to get, maybe use the vocabularies as a drop-down list and get the basics that they want in a machine-readable way.
Thank you. There's one question in the chat so far. Could you please explain further the use of HTTP versus HTTPS? Yeah,
so HTTP is the name, is the unique identification of a vocabulary, a term, and a mapping. They have been used to annotate data sets since before my time here. So everything is connected through HTTP, and this is their ID. We do have HTTPS, of course, but for annotations and for annotating your data, use always HTTP. This is what is happening in the whole of the semantic community, and you will see that we refer to prefixes and the different ontologies that we use always with HTTP because they are all created a long time ago.
Thank you. Any more questions, anyone? I don't see any more that have come through just yet. If there's no more questions, then get everyone back on the screen. Huge thank you to all of our presenters today, Danny and Alex, and thank you to everyone who's come along and asked questions. If there's any more questions, feel free to keep putting them in the Q&A and I'll make sure that we type an answer to them. If you have any feedback about this session or the webinar series as a whole, please fill out the feedback survey. There's a QR code on the screen just now. The positive feedback provides evidence that running these sessions is worthwhile, so we can potentially keep them going. And constructive criticisms let us know what we can improve to make sure they're useful for as many people as possible. It takes less than 5 minutes. I can't express enough how useful the feedback is. Next up, on the 12th of November at the same time, is our next webinar, which is making marine data count, archiving biodiversity data with the UK Data Archive for marine species and habitats, and citing data with DOIs. Thank you again for coming. I hope you enjoyed the session and learned something new. Have a great rest of your day, and hopefully we'll see you next time.
you. Bye.
Thank you.